Hi everyone, welcome to the next video in the Science of Religion series. If you haven't watched the other videos, you're welcome to pause this video and go watch the other ones first. However, this video is kind of a standalone video, so you don't necessarily need the information in the other videos to understand this video, but you're always welcome to watch all of them. So this video is on the Copernican Principle. And so the Copernican Principle, you might say, well, I don't think I've heard that principle or I'm not familiar with it. It's actually one that you've probably heard, but you're familiar with it maybe with another name, or you just didn't even know it had a name for it. So what is the Copernican Principle? It's also called the principle of mediocrity. And this principle states that our planet is unexceptional, that we revolve around a typical star and an average mundane part of the universe, and that there's nothing particularly unusual or special about Earth. Now, if you've actually read any textbooks on astronomy or even been in astronomy class, this is actually one of the principles that are stated at the very beginning of these textbooks, in the basic introductory textbooks, that kind of our planet, our solar system, everything is just kind of mundane and unexceptional. Now, this principle has kind of expanded from not only this idea of it not being very unique to expanding also from a physical understanding, but to also a metaphysical explanation or understanding. So not only is it that Earth is not unique, but also now that we are not here for a purpose. So because it's not unique, that's kind of the principle also kind of means that we don't really have a purpose. We're just kind of here, nothing special about us. And this started all during Copernicus's discovery that we are not at the center of the universe, but that the Earth revolves around the sun. Now, let's go back a little bit to the history of this Copernican principle and kind of the history of this development. So the ancients, Aristotle, Ptolemy, medieval Christians all thought that we were at the center of the universe. That was the most important place. Now, Copernicus and Kepler, as you see here in the slide, believed the sun was actually at the center and that the planets revolve around it. This was the best explanation for the observations and measurements they've made when looking up into the sky and at the sun. So this kind of began this long march of science that kind of continued to demote Earth. Sun isn't at the center of the universe. We aren't at the center of the galaxy. Ultimately, the universe had no center because it was thought to be infinite and eternal. But scientists started to believe that the universe was infinite and eternal around in the 19th century. So then we had kind of this whole idea of trying to kind of fight back and forth with science and what was the general thought at that time of, are we at the center or is the sun at the center? But then that's when science was just saying, nope, the sun is at the center. So trying to change that idea. So this trend in science, this is the Copernican revolution, helped us to see ourselves as less and less significant and less at the center of things. Now, this revolution starts to represent the conflict between science and religion. So science is saying that we are not the center in either area because they disproved that the Earth was not at the center, but the sun was at the center of the universe. But then religion is trying to say, well, no, we're both at the center physically and metaphysically. So now we kind of have this conflict going between science and religion. However, interestingly, this is what is usually taught. You might have learned about this in a history class. Oh, there was this big battle between science and religion, that Copernicus and Kepler, they were trying to sit there and, take us and say we're not at the center, and then religion is trying to say we are at the center, and this kind of became this big battle. But what's interesting, this story that I just told you about what the ancients believed and what Copernicus and Kepler believed is actually false. This is not the correct history of the belief of the Earth. This is just what most people actually learn or hear about in either school or reading various books. So let me share with you the true history. Now, I'm not saying that Copernicus and Kepler didn't realize that, the sun is the center, but it's more of the goal and understanding and how that was recognized and perceived during that time. So let's talk about the true history of the Copernican principle. So Ptolemy, Galileo, Copernicus, Kepler, and even Dante, they all believed that the Earth was not so much at the center of the universe as it was at the bottom of the universe. And this picture kind of displays how they thought about it, as top being kind of heaven and bottom of the universe was where Earth was. So this is kind of seen also in Dante's Divine Comedy. So where you see Purgatory, Paradiso, and Inferno. Here in this picture, you can see that Earth was kind of at the bottom of the universe. And it was thought of kind of as like the cosmic sump, that everything just kind of was placed there to die and decay, kind of the bottom of the barrel. Everything just kind of went there. So if Earth is at the bottom, the surface of the Earth is the intermediate place. And this is where man dwelled. So if you go down into Earth, that would be hell. The surface is where we're at, that intermediate place. And then everything above the surface, upward into kind of space, everything above the moon was kind of thought of being heavenly. So everything out there in space, the moon, everything, the stars, everything that we could see, it was thought to be made out of a different type of material. And this was called quintessence. And it was believed that God dwelled in this heavenly sphere, outside of the celestial sphere of the stars. So kind of as you got further away from Earth and past some of the stars and the planets, you got further away, then that's when you got to where God was. So into Earth, going down, this would be, and down to the middle of Earth would be where Satan dwelled. And this was considered the center of the universe in medieval cosmology. So the way it was believed, it was here is the center, and the center was where Satan or hell was. And then if we went outward, this would be the surface of Earth where man dwelled. And then as we expanded, we would get where the moon and the planets and the stars. And then as we continue to expand out from the center, then we would be in the heavenly realm where God existed. And so this is actually what they thought. Ptolemy and Galileo and Copernicus and Kepler and Dante. So it wasn't that they thought that Earth was at the center and that the sun and everything revolved around it, but they thought that it was actually at the bottom kind of idea, and hell was actually at the center. So what does that mean then when they discovered that the sun was at the center of the universe and everything revolved around that? So what does that actually mean, and what was their goal of releasing that information? So their goal was to kind of help people to understand what this looked like. And so their idea, and this is seen, like I said before, in Dante's Inferno, is that there were kind of different levels going up and levels going down. So there's 9 levels going up, and as you continue to go up, you'd be going toward God and closer to perfection. And then as you went from the surface of the earth and going down, you're going toward Satan and closer to absolute depravity. And so this was kind of the structure that they believed at the time and what they were trying to exhibit. So what was the goal? So when they discovered this, and why do we have this different opinion? So if Copernicus and Galileo and Kepler kind of produced this information and shared it about the sun being at the center and kind of readjusting this perspective, then why do we have this different story? So really what happened is the Enlightenment is what kind of changed things. Now, during the Enlightenment, it was thought that the church is the one that was putting humans in the center. But really, the church hadn't put man in the center, but really was putting God at the center. Here's a quote from Augustine that said that God didn't create the world for man or because of some sort of compulsion, but because he wanted to. So man wasn't the center of God's plan or his need, but really God was at the center. And that's what the church was trying to say. But the Enlightenment movement itself is what actually put man in the center. So it wasn't science versus religion trying to change who's at the center. One trying to say it's man at the center, one trying to say, oh no, the sun is at the center. Really, the church was saying God's at the center. And Copernicus, Galileo, and Kepler were saying, oh, the sun is at the center from a scientific perspective. But as they were saying this, they weren't trying to say, oh, well, that's a conflict. Now we need to change our entire theological perspective. What they were actually trying to say is that the idea that the earth revolved around the sun actually thought to exalt the earth instead of demoting it. So if we're thinking about that structure of here's the surface of earth, going down would be hell, and going towards space or past all the planets into the heavenly realm, we're getting closer to God. So if now we're noticing that the sun is at the middle and earth is rotating around the sun, well, now earth is considered a planet. And they considered all the other planets to be heavenly bodies. Let me go back to this one picture. So if you see here, here would be the earth and hell. And as we were going out, we have the moon, Mercury, Venus, etc. And so the thought was that the planets were heavenly bodies and those were getting closer to God. So now, if we're thinking that now Earth is in this realm, we're actually promoting Earth and exalting it instead of demoting it. So now Earth's surface is no longer that middle ground. So now the middle ground between going up and down isn't Earth's surface, but really now Earth is exalted to be higher. Now is a heavenly body. And so we don't see, Copernicus and Galileo trying to, present these results, these scientific results in a way to compete with the church, but actually wanted to support what the church said and showed that, Earth is actually a heavenly body. Galileo actually wrote poetically about how the Earth, like the other planets, reflect the glory of the sun and is no longer this cosmic dumping ground, but actually was this glorious body. And so this concept and the story that we've heard of Galileo kind of going against the church isn't accurate. He really was actually trying to show the beauty of the earth and trying to actually exalt it and put it at a higher and closer level to God. So, but we go, okay, but I heard all these stories about how the church like persecuted Galileo and Copernicus and Kepler and they, like got killed and all of these things from the church. But so if you're telling me that Copernicus and Galileo and Kepler were actually trying to use their scientific research to support what religious beliefs were, then why would the church persecute them? So let's actually look at the history of that. So like I said, some people think that the church persecuted Copernicus and Galileo due to their view that the earth revolved around the sun. However, that's actually not true. Copernicus was actually never persecuted. He died of natural causes the same year his ideas were published. He had no conflicts with the church in regards to his viewpoint. Galileo, on the other hand, he was censored but not persecuted. But there is a little bit more to the story. He was not really censored because of his views, his scientific views. It was actually more due to the fact that he was mocking the Pope and kind of making fun of Pope Urban VII around 1632. And so he got a little more in trouble with the church because of kind of how he communicated to the church in regards to the Pope. However, even though he still mocked the Pope, he still received his pension for the rest of his life, and he ended up dying peacefully in his bed. So he was not killed by the church and still received support from the church. So this false history, though, that we've heard just continues to be written into textbooks because they continue to want to support the Copernican principle of this issue of the Earth and the universe being mundane, not being special, because if it's special, then it's more exalted, it's a heavenly body, and they'd rather it to be not that case. Now, we've actually seen this. This isn't a one-off case. I just want to give you a little tidbit of information. This isn't the first time that we actually have discovered there to be some sort of historical understanding regarding science that was kind of a myth that has been propagated throughout history. So another one is that Columbus actually believed that the earth was flat, and that for thousands of years, before Columbus, there was lots of scholars and lots of scientists who actually were like, no, the earth is not flat. They've believed it for thousands of years before Columbus set sail, that the earth was round. And in the scientific community, it was a well-given, well understood and accepted fact. But lots of things have been written on that, oh, Columbus sailed so he could find the edge of the earth, or he believed it was flat. But that's also one of these myths that isn't true. He definitely, through other evidence, has been shown that he did actually think that the earth was round and not flat. So then why would the Copernican principle continue? Why has it been so strong and so present for such a long time? So one of the main arguments from those who follow the Copernican principle is they believe if you could just find a place anywhere in the universe where water stays liquid for a long enough period of time, then life will develop just as it did on Earth. And that's their goal. So followers of the Copernican principle continue to want to show evidence of the fact that Earth and our solar system are just mundane and not very unique. And so this is their goal. Their goal is to find just this one little drop of water somewhere, and then that's proof that we are not unique. However, there is some counter arguments to this issue of, is Earth unique or not unique? Even like I said before, Copernicus and Galileo were trying to actually say that we were special. We were a heavenly body. And so now in more modern day science, people are also trying to combat the Copernican principle and say that we are unique and that you don't need just water. If it was that simple, if you could only find water somewhere, okay. But we actually need a lot more to life than water. You can't just find water. You need to find a lot more to actually support the fact that there's life. And they want to try to show that life is a lot more complex than just needing water. So in order to have life, you actually need 26 essential elements for humans. And then if you want the simplest, so we're at the top, most complex. If you want the simplest for a bacterium, you need 16. And all the different species and life forms in between need some variation between 16 and 26. And so if you just need water, well, that's only part of this. This is only one of those pieces. Water and carbon are two of these elements or pieces that you need for human life to exist. Not only do you need these pieces to exist on your planet to be able to have life, but you also need the planet itself to be designed a specific way. So you need the planet's geology and biology to actually interact precisely. So you need the right chemicals for life, so the right biology for life, but then you also need the planetary environment to be tuned to life. So you might say, well, what do you mean by that? Like, what does Earth have that's tuned to life? So for example, the magnetic field that we have on Earth needs to be tuned a certain way to allow for life to exist. Plate tectonics. If the world is just earthquakes and shifting all the time, that wouldn't be very conducive to life. Our carbon dioxide cycle. So we need oxygen to live, and we release carbon dioxide, and we need something that's going to remove the carbon dioxide from the environment so that we have the right balance of that. So these are just a few examples of some of the planetary cycles and environmental things that need to exist for life to be able and possible. So it's not just having water. It's actually a lot more complex than that. However, followers of the Copernican principle want to kind of diminish it. And so you might say, well, maybe this is just an older theory. It's not something that's really like recent and argued. But actually, very recently, there are people that are trying to find life outside of our planet. And so the thought is there are billions and billions of stars that constitute even just our own Milky Way galaxy. So why can't we assume that planets with life are all over the place? Why can't we assume if there's lots of stars that maybe there's a star out there that's like our sun, and that there's a planet like Earth revolving around that sun, and that life could be on that planet? Why can't we believe that? And so that's what believers of the Copernican principle think, that there's probably another one out there. And so there's a few people that have been starting to research into this. So Guillermo Gonzalez, Don Brownlee, and Peter Ward have been looking into and have actually written about what's called the habitable zone. And so this is a zone in the galaxy where habitable planets might be possible. So habitable meaning where can life actually exist with just those basic essential elements that we talked about, both from a geological standpoint and from a biological standpoint. And so what these scientists are trying to say is that there's actually a large number of threats to life. And so it's not as easy as people think, as those that follow the Copernican principle, to find a place that is habitable for life. And what they're trying to show in this is that our solar system, our sun, and our planet is actually unique and is special. So this is kind of a counter argument to the Copernican principle. So let's look at this. So those that follow the Copernican principle, they say, well, let's look at a large cluster of stars. So let's think about, for example, globular cluster M13. Now, you may not be familiar with this one, but this one became really popular a few years back when Sagan tried to shoot a beam message into this group of stars with the idea that there's so many stars here that this would be the highest probability of there being at least one habitable planet. So if there was some life out there, if he shot a message to this group of stars, then it's most likely that that's where you'd have the highest probability of getting a message back. So that was the goal. So let's look at this cluster. So here's the cluster, lots of stars. Shouldn't there be, or could there be, a habitable planet? So let's look at that. So actually, interestingly, you would think that this should be like the best place to find a planet, but really a globular cluster of stars is actually one of the worst places in the galaxy to find life and to find a habitable planet. So I'm going to talk about two reasons why this is actually a really bad place. First is that all the stars there are among the most ancient things in our galaxies. So they're really, really old. And they're made up of almost entirely of hydrogen and helium. There's really no carbon, and they don't really have any heavy elements. And those are the elements needed to make planets. So let's talk about how these elements kind of happen. And what do I mean by heavy elements? So when I say heavy elements, I'm talking about like carbon, nitrogen, oxygen, phosphorus, calcium, and so on. For example, our planet, Earth, is composed of iron, oxygen, magnesium, silicon, sulfur, etc. So if we're trying to find a planet, that planet needs to have heavy elements to make it. So how do we get these heavy elements? So in my Big Bang talk, we kind of talked about how this works. And so how we get these bigger, heavier elements is based on stars. So stars, when they're first made, are from hydrogen and helium. So they have not heavy, they have light elements. And then as they decide to die and they explode as a supernova, then they release these elements, and these elements that are released are now a little bit heavier. And then these elements are going to coalesce into another star. And then when that star dies, they're going to release these elements that are now going to be heavier. These will come together into another star. Then when that star dies, it will release heavier elements, and that's how we get it. So to get the heavier element, you need a star to die, and then you have to wait for another star to die, because that's how the heavier elements are made. Okay? But since this globular cluster of stars are mostly hydrogen and helium, they're really, really old, but they haven't gone through this process of producing heavier elements. So they're still at that stage, that first stage of star development. And so if they are made up entirely of hydrogen and helium, then there's no reason for us to think that there would be planets that have heavier elements around them. So if we need to have a planet, we need heavier elements. And if the heavy elements don't exist, we can't have the planets. All right, let's talk about the second reason. So the second reason is that these clusters of stars are so densely packed. So they're so densely packed together that they wouldn't allow for a stable circular orbit to exist. It's going to be more like an elliptical orbit. So kind of more elliptical than like a circle. Because the gravitational pull of these stars are going to cause kind of this bending and shifting of that orbit. So if there were a planet, so if we ignore point one and we say, okay, there is a planet, the planet did exist, well, could that planet have life on it? So if this is the star and the planet is going around it, so you can kind of think about like our sun, which is a star, going around it. Okay, if it is an elliptical orbit instead of a circular orbit, there's going to be points of time where it's really far away, and then points of time where it's going to be very close. So far away and then very close. So what's going to happen is there's going to be extreme colds and extreme heats. Extreme colds and extreme heats. Where if it's a circular orbit, then it's going to have kind of a consistent temperature because of the distance it's going to be from that star will be the same. Whereas elliptical, it's going to be really far away and then really close. And these hot extremes of hot and cold are not actually good for life. And so this is why the idea of being able to have, a habitable planet in this globular cluster of stars is not very solid. And so this is why the idea of this Copernican principle and this principle of mediocrity is actually starting to die out. And there's actually been a lot of research that's been done recently to kind of show and to support the idea that Earth is actually very unique and very special. And this slightly ties into the anthropic principle of the fine-tuning or the design idea of the universe. But this is kind of going and narrowing down. Instead of talking about anthropic principle, looks more at kind of the laws of how the universe was established. And physics, this is looking more at the actual planets, our solar system, and our sun. And so in my next lecture, we're actually going to dive deeper into this idea of, well, okay, maybe it's going to be hard to find something, another planet, and to find life in another habitable zone. But just because we can't find something else, that doesn't necessarily automatically mean that we are special and we're unique. So in the next lecture, we're going to dive deeper into our solar system and our planet and our sun to look at, well, are we really unique even within our own situation, besides looking at it from the entire galaxy? So I just want to thank you for coming to my talk today, and I hope to see you in my next talk.